All right, here we go with lesson 2.1 in solving our one-step equations. Now, I know from the video, if you watched yesterday's video, the Khan Academy ones, you got to see solving these. The key thing I want to introduce is these two properties, the addition and subtraction property of equality. You can add the same number to both sides of the equations or subtract the same number, and you will have equivalent equations. So if you need to look at what equivalent equations are, right? We use our inverse operations. Now, I know these are easy to solve, but what you're going to be asked to do is justify your steps. And this kind of leads into geometry when you have to actually prove things. So if we're going to prove this algebraically, what we can actually do is write -7, and to get b by itself, we would actually add 3 to both sides. This gives us b minus 3 and then plus 3. So if we are adding that to both sides, that is our addition. The reason is the addition property of equality. Now, after we add that, on this side we get 4 simplified. On this side, we might write it as b plus 0. Well, so what happens when you add the -3 and 3? You get 0. And the property that we are talking about is actually called the inverse property. And I'm not sure if this has come up in your book, it might be earlier, the inverse property of addition. That's when you add -3 plus 3 and you get 0. Now, what happens when you add b plus 0? You get b. What property lets us add 0 to anything and end up with what we started with? That is our additive identity. So when we are looking at these, that's how we're going to use those properties. Now, on your next screen, you're going to see the multiplication and division property. And again, yesterday when you watched those Khan Academy videos, you kind of saw that you can do, what you're going to look at is you're going to be trying to get the variable by itself, isolating that by doing inverse operations. So, again, if I am trying to get this by itself, I can show my division by simply putting it over 4. What lets me divide by the same number on both sides? That is called my division property of equality. Once I've divided on both sides, I can write that I have 1x equals if we are looking at this, 1.6. There we go, it's 1.6. So if I am looking at this solution, I have 1x, and this was simply just simplifying, right? But now, when I take 1 times x, I could say that that's x. What property is that? That is our multiplicative identity property. So I know these are pretty easy to solve, and you could actually check your answer to make sure that you did it right. How do you check a problem? This is going to be really important as they get more complicated, so make sure you understand this. You're plugging in place of the x, the 1.6, and now you put it in your calculator, 4 times 1.6, and it equals 6.4, so it is a check, okay? If we look at this other problem, we are looking at x divided by 4. What do we do to get x by itself? The inverse of dividing by 4 is to multiply by 4 over 1. Do I need to put 4 over 1 on this side? No, I could just put 4. So that I actually have, if I'm looking at this, 1x equals 36. What property let me do that? That was when I was solving the multiplication property of equality. Now that I've done that, I know that 1 times x gives me x equals 36. Why? That is, again, my multiplicative identity. How do I check it? Well, if I'm going to do the check, I might be plugging in and put in, instead of x, I'm going to put 36. Is 36 divided by 4 equal to 9? It checks. Please make sure you're checking as you do your work. Not so much on this lesson 2.1. We'll probably talk about it, and I'll tell you which problems on page 86 you need to do that for, but especially as we get into the next harder problems. So I have, if I look at the problem here, the problem says that we have, and I believe it is just 4/5 times m equals 28. So the opposite of multiplying by 4/5, now some of you could say dividing. We don't want to do division. We want to multiply by the reciprocal. It's much easier. You should know how to multiply fractions. So 28 over 1, 4 goes into 28. That's really nice as we are looking at it. It goes in there 7 times. Here, these are going to cancel and become 1 over 1 or reduce. So m, we could actually say, is going to be equal to So m is actually going to be equal to, in this case, 35. What property did we use? We only really used the multiplication property of equality. So when we are looking at that. Now, you want to try this one on your own. I'm going to check that you got it. Again, you should give some reasons. And then I want you to take a look at, so that we can talk about this in class tomorrow, using the equation m equals 18 and 2/3 m equals 12. Are they equivalent? So you can either check it by solving it, or you can do a check to show me. So I should see that tomorrow on your got it as you are looking at yours. What about the two-step equations? Well, key thing to remember when we do order of operations, we always did addition and subtraction before multiplication and division. So now when we do our problems, or we did multiplication and division before addition and subtraction, we're going to reverse the order of operations. We're always going to do addition and subtraction first, and then multiplication and division. So as you start your two-step problems, if we are trying to solve, and you're going to see this on your notes on problem 1 there, if we want to solve 2x plus 3 equals 15, we are going to subtract 3 from both sides of the equation. Now, sometimes you're going to see it written this way, and this is still the subtraction property of equality. Other times you might see it written like this, and so I'm going to write it over to this side. You might see 2x plus 3 minus 3 is equal to 15 minus 3. I prefer to do it kind of vertically right below the problem. I want to keep everything in order. Those of you that get things out of order, you got to make sure you start doing this in order. So we are looking at putting down 2x, you can see my pen is giving me problems, is equal to 12. That is simply just simplifying our problem. So our justification would be to simplify. I now have 2 times x. The inverse of multiplying by 2 is to divide by 2. What property is that? Well, that is our division property of equality. We divided by the same number on both sides. It left me with, sometimes we might put x and have to do the multiplication property, but in this case, x is equal to 6. So again, what did we do? Simplify. Doing the check. You need to start doing this from this problem on. How do you check it? You're going to place 2. I'm going to put it in a parenthesis. Please make sure you use a parenthesis, not a dot. 2 times 3 plus 2 times 6 plus 3. And the question is it equal to 15? That's what we're trying to check. This gives us 12. 12 plus 3, yes, it checks. 12 plus 3 is equal to 15. So the got it part, you're going to try this. X divided by 2 minus 3. The given is the problem. You're going to do the next step. So look at my example and try and go through this. I want a reason for each step that you are doing. And then please, please, please make sure you do the check. I'm going to see how you did on this and look at it in class. Now this next problem, if you turn your notes over, on the next problem, what we are looking at is we simply want to solve, and this was a story problem and kind of how they came up with it. If you pause this and read through, this is the same one that's in your examples, but it's how we write a equation from a story problem. What are our steps in solving this again? Again, my first step is going to be to subtract 5 from both sides if I want to solve for A. What property is that? That's the subtraction property of equality. So if I'm looking at the subtraction property of equality, I now am left with 1/2. Someone said, can I change it to a decimal? Nope. We start with a fraction, we're ending with a fraction. So 1/2 A, and now when we subtract our, in this problem, 18 minus 5, we get 13. So I have a 1/2 times A equals 13. That was simplifying, right? So if we're putting our justification, it was for simplifying. What is the opposite of multiplying by 1/2? And some of you again might be saying divide by 1/2. I want you to multiply. We want to at this point multiply by the reciprocal. Remember doing that? And this side we don't even have to put 2 over 1. So 26 is equal to A because our 2 over 2 is the same as 1 over 1. So again, what was our reason? Multiplication, property of equality. And again, now if we check it, and some of you might be going, I can't believe she's making me check all these. Yes, it pays off immensely. Some of you sometimes just put like maybe 36 or something instead of 26, and you will catch it then, so that when you take a quiz for me, you are never going to have to worry about your answer being wrong on solving equations, because you will have checked it in your homework, so you're used to doing that. 13 plus 5 does check, it's equal to 18. On problem 3, so we have 2 more that we are looking at in problem 3. You see the problem x divided by 3, and it says when one side of an equation is a fraction with more than one term in the numerator, you can still undo division by multiplying each side by the denominator, and that's what we are going to do. We're going to think of this whole thing as being dividing by 3. The opposite of dividing by 3 is to multiply by 3, or 3 over 1. Those will simplify. I am now going to multiply by 3 on this side. Much easier problem. X minus 7 is now equal to a negative 36. What was our reason for this step? The multiplication property of equality. Now, you can see my pen sometimes doesn't like to work for me. Property of equality. Okay? Now, if we are looking at that, what's my next step? Now, I need to get x by itself. Oh, I'm going to add 7. See how nice and easy this problem is, and it looked ugly. Again, our reason would be the addition property of equality. What am I left with? Now, if I put this down on my paper, x plus 0 equaled, and again, remember, this was adding 7 to negative 36. So when we added 7 to negative 36, we came up with a negative, and we were looking at that 29. Again, what property would that be? Then we add the two opposites. That is our inverse. So when we add negative 7 and 7, that is our inverse property of addition. What that just means is you add the number and its opposite, its inverse, and it gives you 0. If I now put x was equal to 29, that would be my additive identity. Do you see how these are working out with your properties and how we need those properties? Sometimes we'll also use commutative and associative in the same way. Again, how can I check that I did this correctly? To do the check, you're going to write check on your paper. We are now going to check it. How do we check it? We plug in 29 minus 7. And we divide it by 3. Now remember, it should have been, now notice what I did. I put 29. Was the answer really 29? No, it was negative. But let's just kind of keep going through the check to see. This is the reason that some of you need to make sure you do the check. Because if you left this answer as x equals 29, I have to mark it wrong. Why? Because it should have been negative. And when I do this, I would have gotten 29 minus 7. I would have gotten 22. And there's no way I know that 22 divided by 3 is negative 12. So I go, okay, can't be negative 20, can't be 29. Oh, man, that's what I missed. I missed the negative. So negative 29. And now when I do that, I go, oh, yeah, that works out beautifully. Isn't that great? It's negative 36 divided by 3, which does give me negative 12, and it checks. And this is the answer that I want on my quiz, not positive 29 that I'm going to take a point off for. So here's another one for a got it for you to practice. Look at my example. If you need to look at some more online, do so. Think about what are you going to multiply by first on both sides. And then part B says, let's write out part A with two different fractions. So I wrote it out as 1/2 x, like we talked about yesterday, because we would have had, oops, excuse me, that should have been 1/4, right? 1/4 x minus 2/4. Now, you can probably keep the 1/4. That should be 1/4 x minus, and this is going to become 1/2. And now I want you to solve it this way and see if you get the same answer. So I'll look at that in your notes. The last thing I want to take a look at is giving the reasons. So you're going to be asked to give these reasons. I want you to try this one. If you need help, please take a look in your book. What page is this in your book? I wrote on the top of yours, it's page 90, and they actually take you through the whole thing. Try it first here, and then go to your book if you need to.